Dear students, today we'll be seeing a most interesting video in ARM7 series, that is the ARM7 addressing modes. Okay, so this is very interesting, and please listen to this very carefully, because if you understand the addressing modes, then the next coming videos on ARM instruction set will be like a cakewalk to all of you, because this is the main crux of understanding the instruction set of ARM7 also. So please kindly pay some attention to this video, which is on addressing modes. So let me just first name the addressing modes to you. So here we have 7 addressing modes. We know that ARM7 has got 7 operating modes, then it has got 7 interrupts. Now the next 7 is addressing modes. So we have 7 addressing modes. To name them all, the first one is we have immediate addressing mode, then register addressing mode, direct addressing mode, indirect addressing mode, then we have register relative indirect addressing mode. Here I have just written the short form of it, IAM, indirect addressing mode. Then you have based indexed indirect addressing mode and based with scale register indirect addressing mode. So these are the names of the 7 addressing modes that are available in ARM7. Okay, so in this video we'll be very clearly seeing what these each addressing modes mean and how these addressing modes are helpful for us to do programming using ARM7 processor. So let's go one by one. First we will start with immediate addressing mode. I think you would have heard of this mode even when we were studying the lower version of controllers like 8051, and even 8085 also had this addressing mode, immediate addressing mode. So I think from the name itself, it is clear that, when you say immediate, what is immediate here is, first of all, what is addressing mode? Addressing mode is the way in which a data is given to an instruction for it to execute, right? An instruction should be executed. For an instruction to execute, basically what it requires is, it requires a data. So how this data is provided for the instruction to execute itself is known as addressing mode. Data can be given directly in the instruction, data can be put in a register and then you can give the register address, data can be put in a memory. So there are various ways of giving the data. The way in which a data is given is known as addressing modes. This is for those who are not clear about what is addressing mode. So you know that the name immediate here means, what is immediate here? We are talking about data. So here immediate means data is directly available in the instruction. Then it is called immediate addressing mode. So data is given in the instruction. But then here so let's see 2 examples. Move R0, hash 15H. Okay, this is one example. So in this example, as we have seen in 8015 also, whenever there is a hash symbol, the value followed by the hash symbol is the data. So when I give a value in an instruction, the value 15 can be either a data or 15 can even be an address. But how do you differentiate whether it is a data or address is by the hash symbol. So whenever you have a hash symbol, it means the following value is a data. So here we are moving 15 into R0, right? This is what this instruction is asking us to do. But then, this is one way of doing it. But then please remember you may have a question in your mind. All registers in ARM are 32, and all data bus is 32 in size. Then why am I moving just a value 15 into R0? Why can't I? 15 is of course the 8-bit data, right? So why am I moving 8-bit data into R0 and not a 32-bit data? But so far we have been talking that all datas are 32, buses 32, registers are 32, instructions are 32, and so on. Why are we putting an 8-bit data? Come on, do you have an answer for this? Yes. The answer is the entire instruction put together should be 32. You're getting it? The entire instruction put together. Instruction will have an opcode. It has a register name specified. Okay, and then it has to give the data. So suppose if the entire data itself is going to occupy 32 bits, okay, then the whole instruction cannot be done with 32 bit. You're getting it? So whenever you specify a direct data in an instruction in ARM7 processor, please listen carefully. The immediate data value cannot be more than 8-bit. Please repeat this once again. The immediate data value in ARM7 cannot be more than an 8-bit number. The reason is because the entire instruction put together should be 32. So if the number itself is 32, then you cannot complete it in 32 bits. So that is the reason, that is a limitation of this immediate addressing mode. Otherwise, immediate addressing mode is a very easy mode, right? All data can be given immediately and then you can add, subtract, multiply, whatever. But this has got a limitation. You cannot give a number more than 8 bit by using an immediate addressing mode, because the entire instruction should sum up to 32 bit. The data alone cannot be 32 bit. You're getting it? So that is the limitation of having a immediate addressing mode. So data value 15H is moved to R0. That is the meaning of that previous instruction. Now coming to a second example, whenever you are asked to explain about addressing modes in your examinations or anywhere, please try to give at least 2 examples, okay, to make sure that you are really clear with the concept. That's why throughout the slide presentation in this video, I have used 2 examples for every addressing mode. Okay, so the second example is a triadic operation. We have seen that ARM7 supports triadic operation, right? So you can also add 3 values, 3 different values, right? So you can see that you're adding R0 plus R1 plus an immediate value which is hash 25H. Okay, so here you can see that again here the value has to be only 8 bit, because you have to specify 2 registers name and also you have to give an opcode for add instruction. So here it is, it's again, so you're adding the value of R1 plus 25H and then storing it into R0. Okay, so is this clear? So that is about immediate addressing mode. Now coming to the next addressing mode, this is one of the very commonly used addressing modes for all arithmetic and logic operations that take place in ARM7. Okay, because can you tell me the reason why register addressing mode is a very commonly used addressing mode? Because all arithmetic and logic operations are done only register based. Right, the data should be available in the registers. You cannot have the data in memory and then perform an arithmetic or logic operation. It is not allowed, because ARM7 is a strict, rigid, it's a very strict kind of a RISC processor. Okay, so since all data has to be available in register, the most commonly used register addressing mode other than immediate is only this mode. Okay, so here let's see 2 examples for this. So you can see the first example is move R0, R1. In the previous case, we moved a value directly to R0. Here we are moving the content which is in R1 register to R0. Are you getting the difference? So there we have moved a value directly. Here we are moving the content of R1 into R0. So R1 content is moved into R0. The second example is, it can even be an addition, subtraction, whatever arithmetic logic instructions. I told you almost all arithmetic and logic operations in ARM7 use this addressing mode. So here it is add R0, R1, R2. So what happens? R1 and R2 is added. The result of it is moved into R0. So here you have R1 will have one data, R2 will have the second data. Both the data will be added and the result is stored into R0. Is it triadic operation? Yes. So this is the 2 examples of register addressing mode. And this is one of the very, very commonly used addressing modes for performing all arithmetic and logic operations. Now, from the third addressing mode, which we have already named in the first slide, is direct addressing mode. So you can see here, what does this word direct here means? The address of the data. Okay, suppose you want a data, the address of that data will be directly given in the instruction. You need not go around to search for the data. Directly address itself will be specified in the instruction. That is what is meant by direct addressing mode. Now address of the operand is given in the instruction itself. That is the meaning. Now what happens is, again you have a small issue here. You cannot give a direct address in an ARM7 instruction. The reason is because if I have to give a address, full address. Now come on, tell me, what is the size of the address bus in ARM7 processor? It is 32, right? 32-bit address. So if I have to give a full 32-bit address in the instruction, then what about the other portion of the instruction? You have to give opcode, you have to give the register value and all that. So here also the same restriction as we saw in immediate addressing mode, we cannot give a 32-bit address value here. Okay, so what you will do is, you will only give a variable. Okay, please understand this clearly. You will only mention a variable, and see, earlier processors like 8051 and 8085, even when we were doing a lab experiments, we used to mention the address at which the result has to be stored. For example, add this value, and store it at location 4095. You remember, we used to do that in our lab sessions. So what we did is we specified the address, store the result in this address. That's all gone are those days. Okay, they are all old processes. So we were mentioning the address. Programmer was giving the address for the final result to be stored. But ARM is the latest processor, I have told you. So you cannot mention the final address where your result has to be stored or where your data has to be written. All that has to be done by the assembler. You're getting it? So you don't have full control over the memory and all that. Assembler will have to allocate the address location. So all that you have to do is create a variable name, say label. Then the address location of this label will be allocated by assembler. Getting it? So that is a limited kind of, we have some restrictions for accessing the memory. So you have to only identify a variable and tell this variable has to be given here. Then assembler will give a value for that variable. Now here again, a 32-bit value cannot be assigned directly in an instruction because the instruction whole has to be 32. So what I will say, so load R0 with the value in variable label. That is all I have to do. What the assembler will do is the label will be assigned a 12-bit offset value. Now what is the meaning of offset? Now suppose, let me just give you an analogy example. Now I am ordering food through Swiggy, right? And the Swiggy guy is calling me and asking, ma'am, can you please tell the address of your location? Okay. Now there are two ways of telling the address. One way is I'll ask him where it is. Say suppose he says I'm in the RSpuram Annapurna. I can give him, every direction from RSpuram Annapurna. Come left, come right. There will be a, 4-way road. Take the left road. Okay, come this way. Then come 1 kilometer towards town hall. Then you have to, I can tell him detailed address. That is one way. The other way, what I would tell is, I would ask him if he knows any location in Selvapuram. Say, suppose he says, yeah, I know Annamaya Hotel, which is located in Telugupalayam Pirivu. My job becomes easy. So I just tell him, come to Telugupalayam Pirivu. Opposite to that is my house. You're getting it? So what happens is, you are not giving him the full detailed address here. You're only giving an offset value. For example, till Telugupalayam, he knows. Till that hotel, he knows the address. So from there, I'm just directing him with an offset value. I'm telling, come opposite to that. That is the location where I am situated. That is known as offset value. Okay. So you are not giving the entire value. You're just, specifying the offset from wherever you are already located. From there, the offset. Okay. So that is the offset value. So here you can give a 12-bit offset value. Okay, so suppose your current program counter value is 4000. Okay, from 4000 you can specify an offset value. You are already in the location 4000, so that is already you have come to that hotel. Just come opposite to it. So just give a 12-bit offset value. I hope this is clear. So that is how you mention address values in ARM7. You cannot give the entire 32-bit address in the instruction itself. You're getting it? So what you will do is you will have to add the offset value with the program counter value, and then your assembler will give you a address for label. That label value will be taken and loaded into R0. Okay, so this is one example. The second example, so data from memory location label will be taken and loaded into R0. The second example is the store example. So here you have specified a different variable, say result. So what happens? Your data from R2 will be taken and stored at the memory location result. So here result again, you have a PC value. From that a 12-bit offset you will assign or assembler will assign? Yes, assembler will assign a 12-bit offset value from your current PC location. Getting it? So that is how your direct addressing mode in ARM7 will be operating. Now, you can see here in the previous example I gave you move instructions, add instructions and all that. But from now on, all addressing modes, the example will only be either a load example or a store example. Because all the other instructions are related to accessing from the memory directly. But No other instructions except load and store will support memory accessing. You're clear with that, right? So ARM, all arithmetic and logic only is register based. Memory accessing is only for load and store. So from now on, the remaining addressing modes, the example will only be load and store. So don't write an add instruction here or a subtract instruction here. Then they would whoever sees that will understand that you have completely not understood the logic. You're getting it? So that is the reason why you have a load and a store. Now come on, how many locations can you specify by a 12-bit offset? How many different locations can be specified? Yes, 2 power 12, right? So only 2 power 12 locations can be specified by an offset value. Now you may have a question. What if I need more locations for specifying data? So this is restricting me from accessing the entire memory space. It is only giving me a small space in the memory, which is only 2 power 12, but I have a 2 power 32 size memory. So why is this restriction? I don't want this. I want a bigger memory size. Okay, in that case, go for the next addressing mode, which is the 32-bit entire memory can be used. So that is nothing but a register indirect addressing mode. Now what is this register indirect addressing mode is, you will, let's see an example. You will have an instruction like this: load R0, R1. So what did we do in the previous addressing mode? Here instead of R1, we gave a offset value, right? So your current PC value was added with the offset value, and that was the location where you have to take the data and put it into R0. But now you are not happy with that because it is only giving you 2 power 12 locations in the memory. I want the entire 4 GB memory to be used, 2 power 32. Okay, so what do? I put the address value in a 32-bit register. So when it is a 32-bit register, what happens? I can have the entire 32-bit address value. So I will take, so here R1, does it have data or it has address? Yes, it has got the address. So go to R1, you will have an address. Take that address, go to that address location, you will have a data. Take that data and put it into R0. Getting it? So data from memory location pointed by R1. Okay. So whenever you have a square bracket, the value inside the square bracket is the address and it is not the data. You're getting it? So that is the difference between register addressing mode and register indirect addressing mode. When it is register addressing mode, the square bracket will not be there. It will be just R0, R1. So R1 will have the data directly. But whenever there is a square bracket, R1 will not have the data directly. Instead, R1 will have a 32-bit address value. So go to that address, you will have a data. Take the data and put it into R0. Hope this is clear. And of course, the next example is store. So here what happens? You take the value of R0. You need address location to store it. So go and see R1 register. R1 register will have a 32-bit address. Go to that address location in the memory and store the value of R0. You're getting it? Hope this is clear. Yes or no? Yeah. Now this is what is known as register indirect addressing mode. The problem of direct addressing mode is solved there. There you have only 2 power 12 locations of memory could be accessed. But here you can use the entire memory, 2 power 32 locations of the memory can be used. Now coming to the next 3 addressing modes are very similar to each other. Okay, the next upcoming 3 addressing modes. So if you understand the first one clearly, then the next 2 will be very easy for you to understand. And by having a first look at those instructions, you may think that it is really complicated. But I will explain to you in a very easy way, which will make you very clear of what it is. So the next addressing mode is register relative indirect addressing mode. Okay, register relative indirect addressing mode. So it is like address of the operand is given by a register plus a numeric displacement, which is like so for example, let me take the first example: load R0, R1 hash 05. So here what happens is you have to load R0 with a value. That value is specified by a register R1, but not only register R1. Register R1 plus a displacement value is also to be added to it. So what is the displacement value? The displacement value is hash 05H. Okay, so what happens? Your R0 is taken, okay, and then added with hash 05. Hash means it is a data, right? So it is added with hash 05, and then the total will be taken as the address, and that address will have a data. Take that data and load it into R0. Getting it? So that is how you get this addressing mode. LDR R0 R1 comma hash 05H. Now here you can see that R0 is the data from memory location. It is pointed by R1 plus 05. 05 is a direct value that is given in the instruction itself because it is specified with hash. Okay, so your this here in this what happens is all these addressing modes I told you, the next three addressing modes come in three versions. Okay, the first box that I have specified here, this one is a normal version. Then you have your the pre-index version, and here you have the post-index version. So I'll tell you what is the difference between the normal version, pre-index version, and the post-index version. Now here in the normal version, R1 is just added with a direct value. Okay, and then it is the address in that, mean the data in that address location is taken and loaded into R0. But here finally the R1 register content will remain unchanged. Repeat it once again. The R1 content, that is R1 will be added with a value, but R1 content will not change. R1 register will, suppose your R1 is 2000. Okay, it is added with the value 05. So it will be 2005. But your R1 will remain as 2000 even after the instruction is executed. Are you getting it? So that is the first version, which is called the normal version of register relative indirect addressing mode. Now coming to the next version is LDR R0 R1 comma hash 05H. And the only difference is here you have a bank symbol. This is called bank symbol in programming languages. This is called as a bank symbol. Okay, so now what is this? The meaning of this bank symbol is you have again the same thing concept happens here. Here you're putting the R1 with R1 plus 05H, then R0 will be loaded with the data which is located at the location pointed by R1. But here what happens is R1 is added with the value. So R1, suppose R1 is 2000. 2000 is added with the value 05. So now R1 becomes 2005. Then data at location 2005 is taken and loaded into R0. So here R1 changes. You're getting it? R1 is added. So R1 becomes first updated. Then that location you take the data and load it into R0. Are you getting the difference between normal register relative indirect addressing mode and this is pre-indexed addressing mode? Pre-index means the values added with R1. So R1 is now becoming 2005. It is no more the old value 2000. Then that is taken and loaded into R0. The next one is post-index. So I think from the name itself, it will be clear for you. Post-index means what happens is, before that please remember, any value that is given in square bracket only specifies the address. Okay, I repeat it once again. Any value that is within square bracket only gives the address. Now come on, look at this instruction and tell me. Load R0, R1 square bracket, hash 05H. So what happens? First you go to R1. Only R1 has the address because it is given within square bracket. Okay, so take the address from R1, load that value which is in address R1 into R0. Then R1 will be incremented with R1 plus 05. Are you getting it? Yeah. So it is first take the data that is pointed by location only R1, not R1 plus 05, because only R1 is given in square bracket. So take only R1 value, load it into R0. Then increment R1 with R1 plus 05H. Now this is called post-index addressing. You're getting it? So in the first normal addressing mode, you take the value from R1 plus 05, put it into R0. But R1 will remain as, for example, 2000 means it will remain as 2000. It will not become 2000 plus 5. Whereas here, you take the value from R1 plus 05 and put it into, put the data into R0. But here, R1 which if it was 2000, it would now become 2005 because it has been added. Now in the third case, what happens is you're only giving the address in R1. So take that address value, that is 2000 means 2000. Go to 2000 location, take the data, load it into R0. Then 2000 is added to 2005. Getting it? So that is the difference between normal. Here R1 remains the same. Here R1 is incremented, then data is taken. Here data is taken, then incremented. I am repeating. Here R1 is incremented, then data is taken. Here data is taken from R1, then incremented. So this is like, if you have studied programming languages, this is like, plus plus I and I plus plus. Okay, this is I plus plus and this is plus plus I. I hope you know that. That is the difference between pre-index addressing mode and post-index addressing mode. Now you would ask a question: why all these confusions? Why this? Why do you need a post-index addressing mode and a pre-index addressing mode and all that? Now here what happens is, whenever you put a data in an array, okay, suppose I'll tell you again an analogy for this. Suppose you want to copy the songs that are there in your mobile, okay, from your mobile you want to copy the songs to your computer, okay. So your mobile has got, say for example, some 4 GB songs. So there are some million locations you want to copy that songs and then put it into your computer. So you just give the first location, okay. So what you do, from the first location the song will be taken and copied into your computer. Then your location has to be incremented to point to the next location. Then song will be taken and copied. Then incremented, add the next incremented value, go to that location, take the song, copy it. Add the next value, go to that location, take the song and copy it. So what happens, suppose you put this in a loop. That's how the copy operation actually happens. You put this in a loop, okay, and you execute that instruction. So that many times the loop will be executed. Correct? So suppose it is 1 million times the loop is going to be executed. 1 million times you have to access, add. Take the data, add the next address. Take the data, add the next address. So this will have to be repeated so many times. But when you have an instruction like this, it takes the data, the same instruction, adding also happens. So you need not write one more additional instruction for address to be added. Are you getting it? So what you do, suppose your first location is, the song in the first location is 2000. Okay, so you get the song from 2000. Automatically that instruction will add the next address also. What is the next address? 2005. So now when you put again, load it from R1, your R1 will have the next address value immediately. So what happens? You're saving one add instruction in between. Getting the point? So you're saving one add instruction between two load instructions. So you just have to only execute load instructions. This add is inbuilt into the load itself. Okay, so when you load itself, the next address is automatically added. That is the beauty of post-index addressing mode. So suppose your loop is, you're going through the loop 100 times, 100 add instructions you're able to save. Are you getting the point? 100 add instructions you're able to save just by writing it in a post-index addressing mode pattern or a format. Okay, so that is the best thing about this version of addressing mode, which is post-index addressing mode. So what happens is you are able to save 100 add instructions. Okay, so these are all some small things that are brought into ARM7 that makes it really useful for building different appliances, and that is the reason why most of the mobile phones and appliances, they prefer to use ARM7, is because of these small additional things that have been brought into your ARM7 processor. Hope this is clear. So let me just quickly summarize, because when you understand this, the next two will be just 2 minutes, we can quickly finish it off. So here R1 is taken from R1 plus 05 and then loaded into R0, but R1 will remain unchanged. Here R1 is taken from R1 plus 05, added, R1 will change into R1 plus 05, then it is loaded into R0. So that is the symbol bank here. So that's the only difference between this instruction and this instruction. Here the address is only R1. So taken from R1, loaded into R0, then R1 will become 05. So here data is added and then taken. Here data is taken, then added. So that is the difference between pre-index and post-index. And we have seen what is the advantage of having a post-index addressing mode. Clear? Now we'll move to the next addressing mode. I think all this will be very simple. In the previous one, we gave a direct data, right? Here 05 means 05. Usually it should be 04, okay, because the locations change by 4 positions only because the memory is aligned. So assume that this is 04, okay, instead of 05, it should be 04. So because you know, right, because memory is aligned, so first location 0 1 2 3, the next location will be 4 5 6 7, the next location will be 8 9 10 11, so it will be multiples of 4. So this should be 04, then it will be an apt example. Okay, so just imagine that it is 04. Now coming to base indexed indirect addressing mode, here you can see that same as the previous one. Okay, here you can see R0 will be R1 plus R2. So instead of giving a direct value in the instruction, see, in the previous way you have given a direct value 04 or 05, but here instead of that, let me assume that second is also given in one more register. So one register will have half of the address, the other register will have the other half of the address. So what you do, add both, you will get the full address. Okay, and then go to that address, take the data and put it into R0. You're getting the difference? That is the only difference between previous and here. Previous, you're giving an offset value directly in the instruction. Here the offset value is not given directly. Sorry, it's an index value. The index value is not given directly, but it's given in another register. That's the only difference between previous and here. So the name of this instruction addressing mode is base indexed indirect addressing mode. So you have two registers. One register will be the base register, the other will be the index register. Okay, so base register, the first register will be the base register, the second register will be the index register. See, my dear students, if you are not able to be clear with this addressing modes, please listen to this video, for the second time or third time. Only then it will be clear. But please make sure that you understand addressing modes of ARM, not just for studying for your university exam, but it would help you to have an entire idea of your microprocessor and microcontroller subject. You will understand the beauty of why these processors are being used in many applications, and you will start enjoying, and you can also apply them for various mini projects and all that. Okay, so here what happens, here the address is sum of two registers, where one register will act as a base and other will be the index. So this is R1 is base, R2 is the index. Now again, come on, tell me, this also has got three versions. So what is the three version? In one version, R1 register will be added with R2 register, but R1 content will remain unchanged. Yes, you're right. So R1, R2 will be added, that location data will be taken and loaded into R0. But when all this happens, your R1 register will remain unchanged. That is the first version, which is a normal version of base indexed indirect addressing mode. The second version, yes, can you please repeat? The R1 value will be added with R2. Okay, you're having a bank symbol here. So R1 value will be added with R2. R1 will be updated with the added value. Okay, R1 will change. Then that address location data will be taken and loaded into R0. That is pre-index addressing mode. Okay, the next one is ++I. R1, so whatever is in square bracket, remember square bracket is the address. So what is the address here? Only R1 content is the address. So R1, suppose it is 3000. 3000 will be the address location. Go to 3000, take the data, load it into R0. Then R1 will become 3000 plus R2. Getting it? So that is your post index addressing. Okay, so here again, R1 is base, just to summarize, R1 is the base register, R2 is the index register. R1 will be added with R2, the data will be taken from that location, loaded into R0. But your R1 will remain unchanged. That is one version. The second version, R1 will be added with R2. Okay, you have a bank symbol here. R1 will be updated with the addition value, then go to that location, take the operand, load it into R0. This is called pre-index addressing. The third option is you take the address only from R1, because only that is given within square bracket. Load that operand into R0, then add R1 with R2. Okay, so here what happens is, as you know that in the previous example, the previous addressing mode, you can only specify an 8-bit offset value, right? You cannot give a bigger value here. So only an 8-bit value, because it's a direct value that you're giving. But when you want to give a more bigger value for displacement, you can use this addressing mode. That is the difference between the previous one and this one. There you can only give a 8-bit value to be added with the base register. But here you can give both, can be a bigger value. This can be 32-bit and this can be 32-bit. You add it and then you can load the value into R0. Getting it? So that is the difference between the two. Now the last one, but very interesting, okay, is based with scaled register indirect addressing mode. Okay, based with scaled register indirect addressing. Now here, this is, you have to listen carefully if you have to understand this. So one register will act as a base, okay, and other register will act as an index, but that will not be normally indexed. It will be scaled register. So what is the scaling here? Is nothing but shifting. Okay, so you remember in the architecture we had something called barrel shifter. You remember barrel shifter? So barrel shifter, what will it do? It will shift. One content will come directly to ALU. The other content will be shifted from B bus. It will be shifted and then it will come to ALU. Now the purpose of that barrel shifter is for having this addressing mode, base with scaled register indirect addressing. Now let's directly go to that diagram and then we'll come back here. So you can see here you have the ALU. So A bus will give the base register value, okay, and B bus will give you the value which is not directly the value, but the value is shifted. Okay, so one value will come directly through A bus, the other value will come through B bus, shifted and then come to ALU. Now these two values will be added here, and please see that it goes to address register. So which means this portion is mainly used for this addressing mode. So there can be some important questions even in your gate and all that. Which addressing mode extensively makes use of this barrel shifter? So this is the last addressing mode, is the one that makes use of the barrel shifter. So one data will come directly through one register, the other data will be shifted and then it will come to ALU. Then it will go to address register. Now suppose you want the address directly, it will go into address bus. Then from the address bus you can go into memory and then fetch the data and then bring it. And next time it will be just automatically incremented if you put it in a loop. Getting it? So this portion of the architecture, even when I mentioned the architecture also, I told you that this will be useful for addressing mode calculation. So that is what I am covering here. So this portion will be used for addressing mode. Now we'll go back to the previous slide. Okay, now we'll see how this happens. Okay, and what is the purpose of this addressing mode actually. So when you look at the addressing mode, it may look very complicated, but when you understand the logic, it is very, very simple. So you are loading R0 with a value that is located at R1 plus R2, not directly added, but left shifted by 2 location and then added. Getting it? So R2 register is not directly added with R1. Okay, R1 is kept like that, R2 is left shifted, then added with R1. And then go to that location, take the data and put it into R0. This is what happens. Now come on, tell me, why do we need such an addressing mode? We should first understand the logic, right? Just understanding what that addressing mode is not enough for an engineer. Why this addressing mode was made in ARM7? What is the purpose of this addressing mode? Now suppose I want to take a data from address location, say 1, 2, 3, 4. Okay, the address memory location is 1, 2, 3, 4. I want to take the data from 1, 2, 3, 4. How do I do that? Yes, first I will take one register, initialize it with 1, 2, 3, 4, go to that location in memory, take the data and put it. This is one way of doing it. Can I do that? No. Why? Because a register, if I have to initialize, I have to go for direct addressing, the immediate addressing mode. So I will say, move R1, comma hash 1, 2, 3, 4. Can I write like that? It's not possible, because when I write immediate addressing mode, it has to be, the value, immediate value should be only 8-bit. Get it? You cannot write a 32-bit value directly in the instruction. I cannot write move R1, comma hash 1, 2, 3, 4. Not possible, because 1, 2, 3, 4 is a 32-bit data that cannot be directly written in a instruction, ARM7 instruction. So what do? I split it into 2. Move R1 with 1, 2. Move R2 with 3, 4. Getting it? R1 is 1, 2. R2 is 3, 4. Now, I will put one more instruction that will add 1, 2 and 3, 4. Now, Tell me, if I directly add 1, 2 with 3, 4, what will I get? I will not get 1, 2, 3, 4. Got it? If I add 1, 2 with 3, 4, I will not get the value 1. What is my value that I need now? 1, 2, 3, 4. I cannot get 1, 2, 3, 4 if I simply add 1, 2 and 3, 4. So what I will do, I will take 1, 2, okay, and or I will take 3, 4, but 3, 4 will be left shifted 2 positions. Okay, so that there are enough zeros. Then I will add 1, 2 with 3, 4. You're getting the logic? So 1, 2 is taken, kept as it is. 3, 4 is left shifted. Okay, left shifted means you're adding a few zeros in front of it. Then you're concatenating or adding it with the previous value. So now it becomes 1, 2, 3, 4. Have you understood the logic? So that is the logic behind this base with scaled register indirect addressing mode. So you have your R1 value, okay, then your R2 value is left shifted by the number of positions that are given here in the instruction. Here it is 2. So left shifted 2 positions and then added with R1. And go to that location, you will have a data. Take that data and load it into R0. So that is what is this addressing mode means. But what happens to R1? R1 remains unchanged. Suppose R1 is 1, 2. R2 is 3, 4. Okay, left shifted by 2 positions and add it. Then you will get 1, 2, 3, 4. But what happens to R1 value? Your R1 will remain unchanged. That is the normal version of this addressing mode. The next is, as you know, it is the pre-index version. So you have a bank symbol there. So what you do, you take the R1, add it with left shifted value of R2. R1 will be updated with the value. Then go to that location, take the data and load it into R0. This is a pre-indexed version of the same base with scale register indirect addressing mode. The next is, as you know that whatever is given in square bracket is the address. So what is the address? Address is only given in R1 register. So go to R1 register, take that data, load it into R0. Now R1 will become R1 plus R2 left shifted by 2 location. Getting it? So now understood what is the meaning of left shifting? Left shifting means you're scaling the value. Okay, and when you scale the value, automatically you're just shifting that bits by that many positions. So when you want to add 1, 2 with 3, 4, 1, 2 keep it as such, 3, 4 will be left shifted 2 times. So 3, 4, 1, 2 and 3, 4 will be in the same position. So you keep 1, 2 here, 3, 4 you left shifted. So it moves 2 positions. Now when you add, you get 1, 2, 3, 4. That is the basic idea behind this addressing mode. Hope this is clear. So here R1 remains unchanged. Here R1 changes to the location whichever is added with R2, and here R1 the data is taken and then it is added. So it is added here, it is added and then taken, here it is taken and then added. So the thing it becomes it is this common for the last 3 addressing modes. So here whenever a question is asked, what is the main purpose of this barrel shifter is to have this last addressing mode that is based with scaled register indirect addressing mode. In order to execute this addressing mode, you have this barrel shifter, which is the main purpose of having barrel shifter in ARM7. So what happens, again I'm repeating, though I have told it because it's very, very important for you to understand this logic. So here R1 value comes directly, but R2 value comes here left shifted by any number of positions that you want, depending on the size of the data, you shift it by 2 position, 3 position, whatever number of positions, you shift it and then you add it with the R1 value. That goes into your address register. Getting it? So this portion is mainly used for calculating the address during this, base with scale register indirect addressing mode address. Okay, so here the same example that I explained here is given here. So R1 is left shifted by 2 position and then added with R0. So you get 1, 2, 3, 4 as a final address value. Hope this is clear, my dear students. So that is totally about the addressing modes for all of you. So please go through this video at least twice, okay, so that you will be clear with all the 7 addressing modes. But when you start understanding it, it is very, very interesting. 7 addressing modes, and when you understand this addressing modes, the next upcoming video on instruction set will be very easy for you to follow up. So thank you very much, and I would like to take this opportunity to thank all my students who very obediently went through the video and then taken a picture and put it here in this. So I just wanted to add, and hats up to my dear students for your Wonderful response. Keep learning, and we'll do the exam well. Thank you.